Hello guys, welcome again to the page Techie Tech, where we all talk about fun things. So today we're going to be talking about NAT, Network Addressing Protocol. Simply, I'm sure you may or may not have asked yourself, why is that when we check our IP address config, why is that when you check your IP address over here, you get your IP4 address like this, but when you go to the internet, check your IP address, you get a different IP address, this. So that's what we're going to be talking about today. I've had the question in the past, I asked myself that too. So the simple answer is NAT, network address translation. So today I'm going to be explaining to you how NAT works. Simply, NAT exchanges your address when you go public. That's when you browse in the internet. NAT, it changes your address from private to public, because here is your private IP address in your local network. And when you go to look for something on the internet, the NAT technology changes your addresses into a public IP address. So, for example, think of your computer as a house, as a home, and you need something from your neighbor. Let's say his toolbox. You leave and you go to his house, you knock, you present yourself as his neighbor and ask for his hammer or whatever, and he lends it to you and you go back. Now what have happened there is that you left your address, you went to your neighbor's address and you asked for something and he gave you and you come back. That is just how it happens in the local area network, the one in your home or in your office and everything. But now when you think about it in a techie kind of way, what happens is your computer IP address, you see, your computer IP address, which is your house, has gone to another computer in the same neighborhood, that's in the same network, in the same local area network, and asked for something and head back, you see, using your local IP address. So there you don't need any change on anything because it's in your local network, in your neighborhood. And for example, when you want to cast a movie, or a video from your computer, let's say from your computer to your smart TV, you want to Chromecast now. So that you are doing, that is just a simple example. In a local area network, you guys are using the same network. You can share it. You can just send a request to your TV and just start watching your whatever you're watching on your TV, on your smart TV. No, that is within the local area network. Now, when you leave to ask something out of your network, that's you're going public, you need a way to identify yourself in the public. And your local IP4 address cannot be used. Your local IP4 address cannot be used within the internet, because this local IP address is distributed to different local networks within the world. So you cannot use this one, or you're gonna have a lot of conflicts. So you need a way to get a public address. That's where a public address that will be unique to you out there. That's where the NAT comes in. So an image is like when you're here, when you need something, let's say from this computer over here. So let's say you need something from this computer over here. See, what you do is you come to this your computer. It goes to your router and leaves and goes to the computer here. Requests what you want, then goes and come back to your computer. Just within this your network, just within here. It has nothing to do going out here. So here you're working with your local area network. Now where NAT comes in place is when you leave from your computer and you come to your router. And you want to move and you want to go to the web server. You cannot use this IP address, the IP address of your computer. That is the one we saw here. This you cannot use it. This you cannot use it over there because that IP address is private. It's private to you. So what you need is a public IP address. So now let's say. So now, as you can see, sorry, I really want to make it visible. Better explanation. Shit, I messed up there. So so as you can see, you cannot use this your local IP address to communicate. Yeah, you need a public IP address. So you need a public IP address here that is provided by your router to access. Let's say we're talking about a web page of your school, and you want to go to the web now. What happens is your IP address goes into your router and activates your NAT system, the NAT technology. So, and what it does is it takes this your IP, it replaces it by an IP address, by its public IP address, which is provided by our ISP. So depending on the kind of NAT we're talking about, because there are several types, we're going to talk about it in another video. So for short, it takes the IP address and puts a public IP address on it. So you might be requesting it from your web browser or your mail, and all of these different web browsers have different ports. So you get the IP address on your port. That's your address. It's like your address, your home address, and your postal, like your PO box. That's your port. That's when you receive mail. Everything. So it collects it and it changes your address, your public your IP address, and sends the request now to the server in which the web page you're looking for is hosted, and and it keeps a copy of your address into its NAT table. Something is called a NAT table. It keeps a copy, and in pair with the address is the public address it has assigned to you. So it keeps that on the table. It keeps both of them on a table. It keeps both of them on a table. That's on the table over here, called the NAT table. So it keeps both of them on a table here called the NAT table, which is your IP address, which is this one, and the one assigned to you. It keeps it there, and your request is sent to the server. So when that request is sent, we're gonna make the request send as a green. Let's just put it out for better explanation. So when that request is sent to the server with your IP address on it, the new public address, because your request leaves, so you got your private IP address that leaves from. You got your private IP address that lives on your computer with the port number which is depending on the application you use. Let's say you're using your web browser and you're running to a secure website that is HTTPS. It takes now your port 443 and it sends it. So over here you get the public IP address. I don't know if this will be accurate. That is horrible, man. So over here you get the public IP address. Let's just call it P. You get the public IP address that goes to the server as a source. Then when coming back from your server attach that public IP address with the request you sent. That should be the web page, as we said earlier, the web page of your school. It sends back to your router. And when it comes to your router, what does your router do? It has to check if that package is intended to him. So it looks the IP address of the destination of the package sent from the server. As simple as that, it looks the IP address of the package sent and IP destination. So what it does is it checks the IP destination. So slow. That's too smooth. So it checks the IP destination here and checks it on its NAT table to identify if this IP belongs to him in order to collect your package. So if he checks and on his NAT table and the IP address belongs to him, it takes the package. Otherwise, he routes it to another router. So that's why they call it a router. It just routes the packet. But if it is destined to him after he has checked on his NAT table and he sees the IP address and he identifies the IP address on the pair it has saved on his NAT table, it accepts the package, takes the package now and attach it to your private IP. Attach your private IP address to the package. And which goes along with your port. And it does that so that it can identify who on this network. Actually requested for the package. And since as he identified and it's you, because it had kept a copy on the NAT table, that's what the NAT serves. It serves to change your private to public IP address so that you can go out on the internet, and when coming back, it places back your private IP address along with your port and sends the package to you, in order not to make errors and send your package to somebody else on the same network. So once you get once it sees your private IP address, it collects your package, attach it to your IP address and sends it directly to you alongside with your port number, and your computer collects the package and uses the port number to identify which application sends it, that is your web browser. And so that does what, when you take a package from your computer alongside with your port number, when you request for a package with your IP address alongside with your port number, it goes to your router. Your router takes it out to the NAT and save your private IP address, attach a public IP address to you, and then takes now the public IP address along with your package and sends it to the server. And sends it to the server. So now the server takes the request, search for the web page. Takes the request, search for the web page you are looking for. You are asking, serves it to you now with its own IP address as source, and your IP and your public IP address that the NAT gave you as destination. So when the package comes now to your router takes it back to the NAT to identify if that package is its own. If the package is not its own, it reroutes the package to another router. But if the package is his, it after identifying the package on your NAT, it attaches back your private IP address and your port number and sends it to the respective IP address and port number. Then your computer now takes the package, identifies the port number to know which application requested for the package, and in this case that is your browser. Let's say a secure package of 443, port 443. It takes it now and identifies that now is your browser and sends the web page to your browser. So that's just how NAT works. Okay guys, thanks for listening.